Good afternoon to all of you. Am I audible correctly? Am I audible?
Yes, sir. Yes, sir.
Please. Okay, sufficiently audible. So we are starting with our session on circular economy and biomimicking. This is the 13th part of our presentation. First, we will have what is circular economy. Then we will go for what is biomimicking. So let us see the next slide. Circular economy offers the opportunity to move away from the take, make, dispose model by ensuring through careful design and innovative business models that technical and biological materials continuously flow, safeguarding valuable resources and restoring natural capital. This is what is circular economy. That means starting the production from the raw material, then the design of the thing, then the manufacture, then the use, and ultimately throwing away. But instead of getting thrown away, it continues in a cycle, or simply the life cycle of a product ultimately gives way to a second life cycle of the same or different product, and it continues like that, such that there is no end of it. For example, in the Hindu mythology, it is being told that the Atma is always being reborn. You have an Atma, and that Atma is getting reborn, and it never stops. They say that first it will take Janma, like animals, reptiles, etc. And the last birth is again as human being. And again it will go back to the original state. It's a belief system. It's only a Hindu mythology belief. Similarly, any product, right from its raw materials to design, go through its entire life cycle and ultimately will result in another product or same product in a different way, thus continuing the cycle, is called a circular economy, which means the need for the raw materials will be the minimum. You don't have to search for much raw materials. Say, for example, you are having a sari, and after its useful life period as a sari is over, you cut it into pieces, you make some tablecloth, you make some pillow cover, you make some bags, all this. So it starts its second cycle. No part of the sari is wasted. So that is called the circular economy. That means the material is not an economic loss. The material is an economic gain. And now I request some of you to comment some such examples before going further. You can come to the chat box and let me see. Can you quote? I have told an example of a sari going to the circular economy. Can you tell me some other examples where something is going like that to the circular economy, so that the raw material is not wasted and the reused material is going again and again into the economy? Some of you can suggest it. Please come to the chat box. Plastic bottles, very good. Mary Sunita has written plastic bottles. Can you give one or two future recycling of plastic bottles so that people can understand? It is correct. Plastic bottle can go into a recycle in a circular economy. It can be either recycled as plastic or it can be used some other way also. Similarly, baby Tessie is giving oil seed. Bina is giving newspaper. One or two uses also you can say. I agree all this is. Unikrishna is giving metal. Almost all the metals come under circular economy because metals have got what is called salvage value. Whenever you have a salvage value, means the value after depreciation is called salvage value. For metals, except for rusting material like iron, most of the other metals which don't rust, they have got salvage value. So in general, metals are having this circular economy. Even iron is having salvage value because it is used for making new iron. Only thing is, its depreciation may be higher compared to copper or aluminum. Any other examples? Yeah, beer bottles, glass. Beer bottles are basically glass. Glass bottles can be crushed and reused. But nobody is giving any recycling of the next cycle. Okay. Mary is giving plastic bottles can be put to proper shapes and make it as pen stand. One use. That is true. You can make the plastic bottles, cut it into shape, and you can paint it and make a pen stand. Only thing is, its upper half may be useless in that case. That you can use for some other recycling purpose. Okay. And of course, in Malambida, if you come, there is one rock garden there in Malambida, where the entire compound wall is made using glass bottles. You can see that. And that architect who did it is a craftsman. He is from Punjab, Chandigarh. And in Chandigarh, there is another rock garden which I have visited, much bigger than this one. There, all the materials used are recycled materials like what is used in Malambida Rock Garden. It's actually the same person first made at Chandigarh and then only came to Palghat. So it's a reuse. Okay. Now let us come to the next slide. We are going to redefine what is circular economy. The circular economy model is a different way to think about production and consumption that changes the linear. The linear model means take some raw material, make some product, use it, and dispose it. That's a linear model. We call it as a linear model. The other one, when reusing is coming, we call it as circular model. Linear model is very simple. You take a Tetra Pak material and aluminum foil. You do something, maybe packing of a fruity in Tetra Pak, and after drinking the fruity, you are throwing it away. That is a linear model. But remember, Tetra Pak also can be reused if you want. So you can make it as a circular one if facility is there. Okay. So similarly, you can find some ways by which a cigarette packing is coming in hard paper. Hard paper is a very costly material. They bring it in attractive colors, and once you use the cigarette pack, you throw it away. The packet is being wasted. Even the aluminum foil in the packet is mostly being wasted. Then in the circular economy, that linear model is never followed. Everything and anything can be recycled. And designing and implementing circular economy processes into production and design of products and services offer significant long-term advantages. One advantage is cost saving. Cost saving in the sense, if you are reusing something, you can sell it. Like the packet. Pardon? Voice problem is there? Any voice break?
No, sir.
No voice break. I heard some sound, that's why I asked. Okay. I think no voice break. So, from the design stage itself, you have to idealize the matter. Because when you design something, you should design such a way that it fits into the circular economy. It's never thrown out or disposed as a waste. Of course, circular economy models can help reduce the need for virgin materials. Virgin materials means first time use. Take for example the steel used in Kerala. In Kanjikode area, there are more than 30 steel companies, steel re-rolling mills. All these companies are re-rolling only. Re-rolling means they collect scrap iron. And the scrap iron is boiled in a furnace. It is boiled up to 1500 degrees centigrade, and it becomes a liquid form, a red molten liquid. And that liquid is poured into some molds where it gets the shape. That is a remolded steel. Then by a drawing machine, they are drawn into wires or bars. They are called rebars. Rebars means reinforcing bars, which is used in concrete. In India, only 2 companies are making mostly steel from original iron ore. Tata Steel and then Steel Authority of India Limited, SAIL. Most of the other companies are making steel from used steel. That is the best example of a circular economy. And when used steel is not available here, I have seen the companies here going and purchasing old ships, old vehicles, etc. from foreign countries. A ship will have tons of steel. They break it, they bring out here, and they make the re-rolled steel here. So it's a circular economy basically. And the new steel may cost 50 rupees, whereas the old steel they will get for 6 or 7 rupees. So the transformation process is also cheaper, and the vendors, the manufacturers will get a lot of profit when they are re-rolling the steel. At a time, they used to get more than 50% as profit. Now it has come down because the demand for steel has come down because of the conditions prevailing. The COVID situation has brought down the it has brought down the cost of steel, so profit margin would have come down. Let us see the next slide. The linear model is very costly because it's always thrown out. We are not getting it back to utility, and almost the world is going to have nearly 9 billion people by 2030. 9 billion means 900 crores. Now it is 2020. By 2030, the world will have 9 billion or 900 crores of people. And of course, we will have a waste volume, almost per day waste volume, coming to almost 2.2 billion tons or 22 crores of tons daily production by 2025 itself. Population is going to be that much only in 2030. But within 5 years, we are going to have 22 crores of tons of waste every day. And if you compare it from 2002 to 2010 period, what was the waste generation increase? It has almost 150% increase it had in 2002 to 2010 period. 2010 to 2020 period, we are yet to assess. We'll have it. And just see that Americans throw away almost 251 million tons of trash, with 164 million tons ending in landfills. Landfills means they are not reused. They are being thrown out just to the land and it's getting to the landfill. See, the quantum of waste is a huge quantity. So linear model is existing in most of the countries because now we can afford to have it. But soon we will come to a stage where the linear model will be unaffordable and we have to change over to the circular economy. See the next slide. These are the different stages in a circular economy, one by one, how it happens. This slide is unreadable for you. So I'll explain this in another slide where I have given this in word form. This is a pictorial form. We'll come to this later. See the next slide. This is reimagining the future of business. How in future people are going to do business. This will be the office room, the office furniture, and of course the end one is what is going to be the energy source, the sun power. This is how our offices are going to be changed, or even now it is happening. Say for example, when the initial stages of lockdown started, I thought of course it will be ending very soon. So I used to present the sessions by sitting on my easy chair in my hall. But day before yesterday I felt that this is going to last further. So I set up an office room exclusively for presentations where I'm sitting right now. So the offices are changing. Even your home offices will be changing. This is the best example. See the next slide. You see there the net material cost savings in complex durables with medium lifespans you are seeing on the left side. And on the right side, you can see the material cost saving in consumers industries. If we go on to the circular economy, we are going to have a lot of saving, and this is given in million US dollars. This is given how much you are US. It's given us US dollar billions. Billions means 1 million is 1 billion. So this is actually million US dollars. So if you are going to the circular economy, this is an estimate made by some US scientists. If you are going by a circular economy, 630 million or 630 billion material cost saving will be there in complex durables, consumer durables, and of course in consumer industries. Industries means household industries, all come into consumer industries. You will have a saving of around 706 million US dollars. You multiply it again by the conversion to Indian rupee, now 70 plus. That much will be the Indian rupees which we can save if you go for circular economy, the cost saving. How this cost is saved? That much of virgin materials you can avoid because you are reusing the old material. See the next slide. And this was the one I told when we had some small pictures. I told that I'll explain it later. This is what is called the resolve framework. The stages in which we are going to have the circular economy. First one is regenerate. Next one is share. Third one is optimize. fourth one is loop, fifth one is virtualize, and sixth one is explore. These are the different stages. Regenerate means we can just see what are the renewable energy sources and materials which we can use, so that all materials also, reusable materials, we are identifying them. And then the thing is, you can share the assets. You can share the assets means, say for example, now car sharing, carpooling is a common thing. Instead of 5 people using 5 cars, all the 5 can pool into a single car for going to office. If you are working in the same or near office, so resources can be shared. I'll come to audio mode because my power has gone. Okay, then optimizing, where you can reduce the use of material, go for reducing. Many places you can reduce the use of material. Say for example, you are going to buy clothes, and of course, if you are going to buy clothes with more length of clothing required in it, you are going to use more resources. So reducing the length of the cloth usually is a case where you can reduce the resources. Similarly, suppose you are going by a diesel car now. If you change out to an electric car, you can reduce a lot of, you can optimize the use of the energy, because a diesel car may cost 4 to 5 rupees per kilometer run, at least 3 rupees even if it's a small car, whereas an electric car, now new electric cars have come, which cost between 30 to 50 paise per kilometer. So you can reduce the resources. And similarly, you see the looping means you can read there, you can remanufacture the products or components, so that, say, many times when something is thrown out, you can reuse or remanufacture it, so that you can reduce. That is what is called looping, so that you can reduce the cost implication. And you can virtualize. Virtualize means you can dematerialize directly. Dematerialize means one use you are having, you can convert it to another use. All this you can give some examples after this slide is over. Then you can explore. You can explore means you can replace some old things with some new things, so that the old thing can be renewed. It can be used with certain renewals. Say there is one door at your home which has got damaged a bit, but you can repair it and you can use it again, so that the cost implication is very, very less. Say I'll quote one example. I had a wooden cot at my house which was odd looking. So with the same cot, I instructed a carpenter how to explore it and how to make it a new one, and with a new varnishing, it became almost pretty new. So cost implication there is only the cost of the carpenter, no cost for the wood. Wood is the same which was there in the old cot. This is how we can have. Now I request some of you to give some examples for each one of this, to generate, to regenerate, to share. I think I am coming to the chat box. Please tell me one example for regenerate. Anybody? How you can regenerate? That means you can shift to renewable energy and materials. Just see how you can regenerate. Someone can tell me. No one is there on the chat box? No one has come with any idea for regenerate, for share, for optimize, for loop. No one is there. See? Can you give one example each for? It is all written there. What is meant by regenerate? What is meant by sharing? What is meant by optimizing? I just want to see how many of you are listening also, so that you can get a grasp of this. One example, please give for regeneration. Maybe connected to your households, or connected to your locality, or connected to your office. One example for regeneration. Regeneration is the first phase in, okay, power from waste. Yes, very good. Power from waste is very good. Then solar cars. Solar cars is, of course, okay, you can also approximate it to regeneration, but it comes into some other, okay, let it be. Then anybody, one example for sharing of assets. Carpooling is one example I told. I want another example. Sharing carpooling is definitely, because I told that example. I want somebody to say another example. No one is knowing. Only carpooling is there, nothing else. Any other example? Public transportation. Yes, public transportation is one very good example of sharing. For example, in countries like Singapore, they charge very high for purchasing a car so that people will resort to only public transport vehicle. That is why their public transport vehicle is more convenient and comfortable also. They take care of it. Okay. Then another example for optimize. Give an example for optimize. By Shailesh has said odd number and even number restriction for private vehicles. Okay, that's also a good control. Now come to the third one, optimize, where we can improve the performance. Optimize. Anybody? What is an example for optimizing? Give an example of optimizing. Yes, why taking so much time? The reaction time is very high. Optimizing fuel efficient systems. Yes. For example, fuel efficient system means instead of using a car which has got 10 kilometers mileage, you can go for a car which has got 25 kilometers mileage. So you need fuel less. Electric cars is an example of optimizing. Okay. Energy efficient AC. Very good. Instead of going for a 3-star AC, you can go for a 5-star AC, which will roughly reduce 10 to 20% of the energy requirement. Today I have done an activity for this. An ordinary light was replaced with an LED tube. LED tube of 36 watts capacity will give the power of a 200 watts incandescent light. See? So it's an energy efficient appliance. So similarly, now looping. Looping means remanufacturing or recycling or digesting anaerobic material, etc. Any example for looping? These are all parts of the circular economy, how you can recycle or recirculate your materials. Just give an example for looping. That means one product you can convert to another product, or one used material you can recycle to another material. Anybody? I know I have so many examples for all of this, but I want you to give one each so that you are following what is being discussed. Reusing old electronic parts to create new electronic device. Okay, good. All electronic parts can be used for. Earlier, we used to have some people who used the electronic parts in radio and made new radio. Nowadays, I think people don't take that. Then plastics. Plastics you can remold. Of course, as you know, there are two types of plastic: thermoplastics and thermosetting plastics. In that thermoplastics, you can remold any number of times. But thermosetting plastics, it will be very difficult. Thermosetting plastic will have a loss also. They will burn. Okay. Now coming to the next one, virtualize. Virtualize means what? Dematerializing directly or dematerializing indirectly, both ways. Can give one example for this. Yes, give an example for virtualizing. Any example? Virtualizing means dematerializing directly or indirectly. One best example is, nobody has quoted it, one best example is getting all the books on a pen drive. You are saving so many trees. You know, a pen drive, now we are getting 124 GB pen drive. A 124 GB pen drive can save so many trees. Why? Each ton of, say, normally a tree will be 200 to 300 tons if it is a grown-up one. So converted into paper, it will come to that much. See, suppose you want to buy some 1,000 books How much costly it will be? Thousands of books you can copy onto a small pen drive. So that is the best example for virtualizing. That is the best example I can say. So changing the mode of, or you can, okay, now let us come to explore. The replacing the old with attached to new facilities. Fossil fuel to solar. Okay, another example. Ashwin Raj has told that fossil fuel to solar. Any other example? Mobile phones. Okay, that is good. Mobile phones is also an example because instead of carrying big electronic equipments, huge laptops or huge desktop, now everything you can have with a mobile phone. So it is miniaturizing the technology by which you are exploring the possibilities of many other things. And nowadays, a small mobile phone has got the capacity more than a big laptop many times. Now come to the next slide. Why we should go for circular economy? Circular economy is a part of our DNA, and it's a part of our activities, and it gives leadership in products and services and make people invent new things. Also, it makes good business sense. Always circular economy is more cheap, more replenishing, more or less depleting the resources. You are saving the Earth's resources. And of course, it poses some challenges in some cases. For example, the mobile phone was a real challenge. It took years and years to come to that miniature level. Then collaboration is possible. People can collaborate themselves to reduce the resource utilization. One example I can say, the cement companies are making a lot of fly ash. Cement companies do need a lot of fly ash, whereas thermal industries are creating a lot of fly ash. So earlier, the fly ash coming from the thermal industries or thermal power plants used to be polluting the place. Now they don't let it to escape. They have got electrostatic precipitator and they collect it and they sell it at very high prices to cement industry. See, so it's a collaboration. A waste material from one industry coming to us production material as a raw material to another industry. So this is a collaboration. And disruptive innovation to transform other industries. Disruptive innovation means, suppose you are reducing the products of one industry, you can come into, say for example, after the destructive distillation of crude oil, you get what is called coal tar. Coal tar is also called bitumen. And bitumen is a very good material for road surfacing. We have got what is called bituminous material. Actually, it is the disruptive distillation of crude oil which ends in such a material, and it's a throwaway material, but it's not simply throwaway. We use it, we need it for road tarring or surfacing of roads. See, that way things can work, things can contribute to each other. Now see the next slide. The one of the best example is Tetra Pak. Instead of plastic packaging, now people are going for Tetra Pak. Tetra Pak means earlier paper pack, and sometimes inside that an aluminum foil may be there. Both are reusable. Unlike plastic, it has got the advantage. Plastic you have to categorize first, whether it is A, B, C, D, or E, like that you have to categorize for recycling. But Tetra Pak doesn't need any recycling. The cover of Tetra Pak is good for making hardboard and plywood. Hardboard basically. Tetra Pak cover is good for hardboard. It can be recycled. And if there is an inside aluminum foil, it can definitely go into aluminum industry again. It can be reused for making aluminum. So aluminum foil is somewhat pure aluminum. So you can reuse it. Okay, next slide, please. So Tetra Pak, there is one more information about Tetra Pak. See, you can see the renewability and recycling capacity of the Tetra Pak. Tetra Pak is average 74% paper. That means it can be used even for paper making. Only thing is, whenever recycled material is used for paper, you can make only newsprint paper. You cannot make white paper. Because if carbon content is there in the material, pure white paper is difficult to make. That is why pure white paper is always used from pure lignin or pure trees or pure plants. Whereas the newsprint, which is a bit colored, can be made even from reused or recycled paper. That is advantage. And over 55% of the US people have access to cartons, and recycling is done in almost 48 of the states there. In India, the Tetra Pak recycling is there only in 1 or 2 metropolitan cities. I don't know whether in Kerala anywhere this Tetra Pak recycling is there. But in North it is there. 2, 3 I have heard about. So Tetra Pak recycling now will become common. One example is, say, before the lockdown was over, lockdown was there, I used to buy milk in plastic packets, plastic packet milk of Milma. Now when the plastic packet has to be refrigerated, you have to be kept in fridge, you have to use it. And when the lockdown started, I stopped that and we started buying Tetra Pak milk. Tetra Pak, very good quality milk is available from Amul. Amul milk is there, Tetra Pak, and Nandini milk is there. Good Life Nandini milk. Both are good quality. Price is also very close by, because an ordinary milk packet of half a liter plastic packet costs now 23 to 25 rupees based on the milk. And this packet is also between 23 and 25. See, cost saving is there. Of course, somewhere on packet it is written nearly 30 rupees, but if you buy in bulk, you may get between 25, around that range. So I'm buying in bulk, and you can keep it without refrigeration for any number of days. So Tetra Pak uses, that is in Tetra Pak. So its use is going on the increase I am feeling, because when I talk to some of my friends, they said they are also buying the Tetra Pak milk because you can keep it in large quantity at home. Even for a month, we can keep the Tetra Pak milk without refrigeration. It won't get deteriorated because it's so processed. And moreover, the processing is done by big companies like Amul or Good Life, so it is good. So maybe I feel that in days to come, the Tetra Pak use in India is going to be high. It's environment friendly. Plastic packets, in metropolitan cities and towns, there are people who come and collect the milk packets. In my area, which is a village area, it's a panchayat area, I have not seen anybody coming and buying or even freely taking away the milk packets. In town, it may be there. So Tetra Pak is environmentally friendly in that way. Even if no one is coming to collect it, we can just burn it, because it is only paper, it's not plastic. Burning paper is not that harmful like burning plastic, where so much dioxins can escape. Okay, so Tetra Pak use is definitely going to increase. Now let us see the next one. What are the resources that, of course, it is seen that the Tetra Paks will give rise to only 20% of the carbon emission compared to other materials. That is one advantage, because it is basically a cellulose material. Okay, see the next slide. So we have to ultimately go from a linear to a circular economy. A linear economy is one I told, make, use and dispose. A circular economy is what you see on the right side, circular. What you see on the left side is linear. A circular economy is what you make, use, reuse, make, reuse, like that. That cycle will go on continuing till the last moment. Of course, you can never throw it out, because paper. Why should you throw it out? You can make hardboard out of it, and again the hardboard can be reused for making hardboard. Like that, it can continue. Okay, so that is why the goods of today are the resources of tomorrow, of yesterday's resource prices. That means reused materials are always cheap, and you are getting at previous. Say, for example, the material you used is somewhat old, like the gold. If people are having sufficient quantum of gold, in many of our households, we have got gold which has been kept there for hundreds of years. In my family, I have seen gold gifted by grandparents, their grandparents, like that. Some people keep it, some people remodel it. Anyway, the gold is the same thing. Even if you remodel it, the gold is the same thing. Like that, it's a circular economy actually. The gold in Kerala is basically a circular economy, except for some emergency purpose. You don't even remodel it. You can clean it and use it as such, even if it is 200 years old. Okay, coming to the next slide. We are going to the next topic. So I think circular economy you have understood. What is linear economy and what is circular economy? And of course, long back there used to be so many high quality general purpose on circular economy. Nowadays, I am not seeing much on it. In the 70s and 80s, in economics, studies on circular economics was very agile. Now, not that much, because everything has got its own period. That period, things will be more popular there. Now, let us go to the next topic, that is biomimicking. Let us see what is it. Next slide, we will see. Let us listen to a small video, and then we will see what is biomimicking. വീഡിയോയിൽ വരുന്നില്ല.
We're going to talk about biomimicry. What is it? Bio means life, mimicry means imitate. So biomimicry is the practice of imitating life. It looks to nature to provide inspiration and direction to sustainably solve our most pressing challenges. It is innovation inspired by nature. Human beings are clever. We've created cities, economies, and whole societies. But at the same time, and without meaning to, we've also created massive sustainability challenges for future generations and ourselves. Biomimicry is a way to address these problems by creating policies, products, and processes that are adapted to life on Earth. The idea goes like this. Plants, animals, and microbes are amazing. They have spent billions of years engineering and testing ways to thrive on the planet. 3.8 billion years to be precise. That's a lot of research and development. After all this R&D, what didn't work doesn't exist anymore, and what surrounds us has to learn to survive. Solutions to challenges large and small are all around us. We just need to look. Here are two examples. Sustainable energy provision is a massive sustainability challenge. The race is on to find economically viable sustainable energy solutions. Biomimicry asks, what could we learn from nature that could help us produce sustainable energy or make more efficient the current alternative technologies that are already out there? Seemingly large and unwieldy, humpback whales display surprising agility in the water. This is due mainly to their flippers, which have large irregular bumps called tubercles across their leading edges. Inspired by these flippers, a company called Whale Power has developed turbine blades with bumps called tubercles on the leading edge. These blades promise greater efficiency in many applications, from wind turbines to hydroelectric turbines, to irrigation pumps to ventilation fans. In fact, using these blades to catch wind could provide up to 20% increased efficiency, making this type of alternative energy competitive with other energy sources. Thank you, humpback whales. Here is another example of biomimicry in action. The Shinkansen bullet train is one of the fastest trains in the world. Offering high-speed travel between several of Japan's metropolitan areas, it used to travel over 200 miles per hour. But every time the train emerged from a tunnel, air pressure changes made a sonic boom like a large thunderclap, causing people 1/4 mile away who lived along the train line to complain. Japan has strict noise pollution laws, so this had to be solved. The train's chief engineer was a dedicated bird watcher. He asked himself, is there something in nature that travels quickly and smoothly between two different mediums? The kingfisher dives from the air into water to catch fish and produces almost no splash at all compared to similar-sized birds or animals. Modeling the front end of the train after the beak of kingfishers resulted in a quieter train, one that uses 15% less electricity while traveling 10% faster. By emulating nature, the bullet train designers were able to solve an important problem. Imagine what might be solved by turning to the world around us and asking, what would nature do? Check out biomimicry.org and asknature.org to learn more about this exciting practice of innovation inspired by nature, as well as
Okay, now we'll come back to see what is biomimicry. I just wanted to show you one small video just to understand overall what it is. Come to the next. Click once more, please. Once more. See this definition. Biomimicking or biomimetics, also known as bionics, biognosis, biomimicry, or bionical creativity engineering. It's all the same. These all terms are meant for the same. In your syllabus, BTech syllabus, it is written as biomimicking. Normally, we write as biomimetics. Anyway, whatever it is, these are all the application of biological methods and systems found in nature. That is the first thing you have to keep in mind. Whatever is found in nature, the study and design of engineering systems and modern technology. Taking the design ideas from the nature. Taking biomimetic refers to human-made processes, materials, devices, or systems that imitate nature. That means when designing something, while just now they explained about making the bullet train. The bullet train is made in the shape of the beak of the bird so that it can move faster without making air ripples. That is it. So that a fast-moving bullet train traveling at 200 or 300 kilometers per hour will not make a huge impact on the environment. That is why that shape is taken. Now, can you give me one or two examples where we use the nature's design? We use the nature's design for man-made things. One or two examples can you give where design we are borrowing from the nature? Let us see whether you are aware of these things. Some examples where the nature design given by the nature is best for us. We are using it. Yes, lotus leaves. Lotus leaves paint. Paint is having the components of lotus leaves where water will not stick on. So apex paints or such paints which are used for external purposes are having coatings similar to that of lotus leaves. Then helicopter. Helicopter we learned from where? Helicopter as such is, okay, maybe the bird's shape is there, partly borrowed from the birds. Okay, then aeroplane structure of a bird. Aeroplane is, okay, aeroplane is borrowed from the bird's shape. True. The wings and the body are in the, then walking stick of blinds. Walking stick of blinds, where from it is copied? Just tell us where from. Then Shailesh says mimosa. Of course, I want you to just say from where it is also taken. What for it is. Say, for example, bird's shape is taken in aeroplane. It completes that statement. Give a statement like that. Don't say only one side. Okay. That's all. Nothing else. I'll tell you one incident. I don't know whether I have told this earlier. You know, the tallest building in the world is Burj Khalifa Tower. And when that tower was to be designed, it was entrusted to an American consulting firm. What they first did is the American structural designers first came to Gulf countries and they went in search of a natural form. Gulf is having so huge wind force. They went in search of a natural wind form which can withstand the wind effectively. And they found that there's a flower in the Gulf countries. They call it as a spider lily. Its technical term is Hymenocallis. They found that this flower has got 4 petals and it is effectively resisting the wind. They took the flower samples to wind tunnel study, and they found that if these 4 petals are reduced to 3 petals, the wind resistance is more effective. And that flower shape, actual flower shape is 4 petals, and the revised or modified shape is 3 petals. And that is the top view of the Burj Khalifa Tower, even now. If you take the top view of the Burj Khalifa tower and compare with the Hymenocallis, you will see the only difference is the Hymenocallis is having 4 petals and the Burj Khalifa tower is having 3 petals. Okay. And then, termite mount cooling in buildings. Okay. Termite mount cooling in buildings, I'll be showing a PPT here, how the termite mount concept is given in cooling buildings. That's a green building concept. We'll come to that. Now, take the next slide. The word meaning of biomimicry or biomimicking. Bio means life, and mimesis means imitating. So, imitating life forms or just copying from the life forms of nature. Take, for example, the man who designed the building always used to resort to the trees because the trees have got roots, and roots are what keep the trees on the ground. So our design of piles, our design of footings, these are all based on the basic concept of the roots of the trees. The man who made the ship learned from the fish. The man who made the aeroplane learned from the birds. Like that, we are learning a lot of things from the nature. So biomimicry simply means imitating the life forms or the nature. See the next slide. Of course, the first the term was coined by Janine Benyans, and of course now it has been modified a lot, the concept itself, or from the nature or learning from the nature, etc., etc. Now come to the next slide. So the aeroplane imitated the wings of the birds, how the air flows around the wings of the birds. That is why you have seen the wings of the aeroplane has got flaps. While landing and taking off, these flaps will be adjusted. Flaps will be adjusted like the wings of a bird. That is how we can control the landing and taking off, by adjusting the inclination. Those who have traveled by plane would have noticed that while landing and taking off, the inclination of the flaps on top of the wings will be adjusted, just like the birds adjust their wings. Okay, see the next slide. So nature is a teacher. We have to learn a lot from the nature. When faced with the problem, ask the question, what organism needs to solve the same problem to survive? So in nature, different organisms, different living organisms have faced your problem earlier. Say, for example, if you are faced with rain, you have seen the nature which organism, which plant or animal has to face the same problem. Suppose you are faced with a very high, very low temperature, see which animal in the world is facing the lowest temperature. It is actually the polar bear. So you take the skin of the polar bear and the fur of the polar bear so that you can protect yourself from the very low temperature. That is why the Eskimos who live in the polar region, they kill the polar bear and take their skin and their fur, so that will be a protective mechanism for them in very cold. It's always sub-zero temperature, and moreover, Eskimos are living inside ice dens. They don't make house above the earth. Their house is below the surface in ice only. So they use these natural materials. See the next slide. Inspiration, we have to look to nature to transform society. So for the needs of nature, needs of human beings like water, energy, materials, food. That is why we are saying, we are predicting that the solar energy is going to be the ultimate answer. Why? Because all other organisms on this earth except human beings are totally dependent on solar energy. And of course, all other things, all other organisms except human beings are dependent on the nature for food. Human beings are the only species who convert the natural materials and make artificial food. All other organisms use natural food. So these are something which we have to learn from the nature. See the next slide. When we compare the human beings with the other organisms, we human beings are having a linear, last examples we have seen. what's a linear economy and what's a circular economy. Every organism except human beings follow a circular economy. You see that no other species on this earth is using any artificial material. Only when you say it has been spotted that some cows and goats have got plastic bumps inside their stomach. That is only because the man-made plastic bumps were here. Otherwise, they would have never eaten the plastic. So normally, all other living organisms except human beings have got a circular system of materials. And they are all decentralized because the human beings only make centralized system. Human beings only make cities. Human beings only make, collective living. All other organisms, all other beings, all other animals don't have collective living. Even if they have got collective living, it is actually scattered collective living. Like you would have seen herds of elephants or herds of other animals, but their collective living is only even in a forest. There will be so many such herds. They won't have any city of elephants or city of dogs like that. They'll be scattered. So that means they are more cooperative in the same gang. In the same group, they are very cooperative. Whereas man is born alone and die alone, and he is so selfish in his life on this earth. So he is independent and individualistic. And man is more inflexible. He wants to make comfort out of everything. Whereas the animals get adjusted. The animals and plants get adjusted to the nature. So when you get adjusted to the nature, the impact on the nature will be less. But when you are trying to transform the nature, you will become singular and your impact will be more. Okay, see the next slide. And of course, what we have done ultimately, human beings have done ultimately, is we have depleted most of the natural resources. And the fossil fuels will be soon over. Within 30-40 years, all the fossil fuels will be over. Our natural habitat we lost. Our natural habitat was thick forests. Now we have come to the cities where there is no trees at all. So the natural habitat is lost. And climate change we have brought in. And we have endangered many species. Many species, especially there is a book which is called Red Data Book. Red Data Book is the book containing the names of the species extinct, like the dodo species. Many species have extinct, and plants and animals, because we involved in it. And of course, there is a bioaccumulation of toxins. Bioaccumulation means accumulation inside the biotic environment of toxins. Toxins means poisonous gases and liquids and metals. They're all toxins. Toxic means poisonous. And dependence on petroleum. We are dependent on fossil fuels, petroleum, whether it is petrol or kerosene or diesel or naphtha or gasoline, we are dependent on it. All these have ultimately created problems for us. Human beings always do have problems. See the next slide. And the result of which life creates conditions conducive to life. We create it such that we make our convenience and comfort more. Whereas the other organisms, they have only very limited means to do that. And obviously, the other organisms have only energy from sunlight. They don't have energy. No organism other than human beings can use fire. Only the human beings can make fire and preserve fire. None of them can do that. Okay. Now, none of the other animals or plants are giving any toxic pollution. Only human beings are giving the toxic pollution. And the funniest thing is, none of them are generating waste. Say an animal is taking some food, the remaining is leftover. That leftover food will be such that it will dissolve into the nature. That will be biological, not in a plastic can that an animal eats. So the counterparts we have got on this earth, none of them do pollute. None of them make the earth hazardous. We are the only species who do it. And that is why we say man is the only self-destructive species. See the next slide. So, what are the principles of biomimicry? There are 9 principles which we use in biomimicry. If any of your efforts conform to this, you can say that you are going for a green engineering. First thing is, as much go for sunlight. Sunlight, of course, day before yesterday, news has come that ultraviolet rays kills the coronavirus than any other medicine. Anyway, that's a new information. So sunlight is even killing virus to that extent. Now, there is no other medicine for coronavirus, but ultraviolet rays are a good medicine for it. A recent report has come. So if it runs on sunlight, if it uses only energy it needs, that is no wastage of energy, it's fit into the function only. There is nothing extra made. Say, for example, you want the light of a 20-watt bulb. If you are going for a 100-watt bulb, it is extravaganza. So it is more than what is required for the function. It is not a biomimicry principle. And everything can be recycled. Whoever or whatever cooperates can be rewarded. Then diversity is there, unity in diversity. Instead of going depending on a single source, maybe electricity made from hydropower station or electricity made from thermal power station, we have a varied option like solar energy, wind energy, thermal energy. All these things are there. We can say it conforms to biomimicry because the nature has got all these combinations. And then demands local expertise. It's not high tech. If something is very high tech, we cannot go for it because our system won't permit it. Then we have got curbing of excesses within. Only use whatever is required, and then taps the power of the limits. Within limit only we use everything. We are not going for excessive spending of energy, power, or money or anything. See the next slide. Examples of fitting form into function. Let us see some of the examples. Nature has got different forms. See, these are all forms of organic beings. All these are fingers of certain living organisms. So these are sticky feet. Actually, like lizard, such organisms do have sticking feet, so that if they climb a wall, they can proceed onto it, like the Spider-Man. I think they can proceed onto the wall and they can climb. See the next slide. Then some of the organisms do have natural tails, which they can attach to somewhere and climb. Like you would have seen the monkey. If at all it is falling from a tree, immediately it loops its tail around it so that it gets itself hung on it. So many organisms have got such long tails which can be attached. Even some plants have got such tails. They attach it to some grown trees and they climb on the trees. They are like they are called the climbers. They have got this. The tail is with them. See the next slide. And whales. These whales have got a capacity to swim very fast. They inhale water and exhale water, not for drinking purpose. They just inhale water and exhale water. That means they get a jet force. They can move very fast. Okay, see the next one. And the kingfishers, you have already seen. Bullet train is made in the shape of the kingfisher so that it can move fast. Kingfisher has got very least air resistance, so they move very fast. See the next one. Bionic car. Bionic car is having less consumption because it is made in the shape of the box fish. So movement is made faster. Box fish can move very fast. See the next. This is somebody mentioned. This is the termite mound. The termite mound is having some air vent at different locations in the top. That air circulation is perfect. Though we feel that there is no air circulation, the termite means white ant. In Malayalam, we call them as chedale. That is termite. So the termite mound has got very good ventilation inside. It's air conditioned inside, not temperature also. That is why the termites are happily living inside. And many times the termite mound may be just above the ground, and many times they, instead of making the mound, they make termite homes beneath the ground also. Well designed. They have got well designed houses inside. Even if you break a termite mound, you can see that inside a well designed house is there. See the next slide. The shark skin. Shark skin has got very good capacity for speedy movement in water. So swimmers use the shark skin type designs for their bunions. If possible, they use even the original shark skin so that they can move very fast. You know, Michael Phelps was the world record holder in swimming. He used to use shark skin. Shark means shrav. shark skin he used to use for his t-shirts. See the next one. So nature can solve many of our problems, provided we resort to nature. Some of the cases where we stick on to nature are given here. See the next one. So mainly 3 types of biomimicking. 3 types means mimicking the form, that means design, mimicking the design, like a tall building mimicking the tree, a bullet train mimicking the bird, or an aeroplane mimicking the bird shape, or a ship mimicking the fish shape. These are all shapes. Then mimicking the process. Process means, say, the muscle manufacturing glue, which we make based on what the muscle is making. That glue which the muscle makes is very sticky. So like that, that is an organic glue which the muscle makes. Like that, we make original glue, which can match the muscle glue is there. Then spider's web. The spider web is very strong. Compared to the spider's size, the web is very strong. So you can even learn how to make a good net. The fishermen can use the technology. Then third one is mimicking ecosystems. If you make a particular ecosystem where an organism live, similar to that organism we can live. Suppose you are finding an organism which is very calmful, very calm and peacefully living in an environment. That environment we can mimic in our own house, so that we'll be very cold. That is how we have mimicked even the air conditioner. So we found that low temperatures will make us more calm and more comfortable. So we are mimicking. The creatures at low temperature are mostly peaceful in nature. See the next slide. So the last slide in this, as a summary, we can say that we are facing increasing pressures of energy, water, materials, and food. So we have to reduce the use of all these things. And then nature has already figured out or designed how to avoid the complex problems. So if you observe the nature, the basic quality required for an engineer is observe. You'll get the solution from nature. You always get the solution from nature. I don't know whether I have told you the story of Vishwesharaya, who always used to observe the nature to find solution for engineering problems. Nature will give you the solution for anything. So observing the nature is the first quality required for an engineer. Then use ecological design principles to inspire engineering projects. You can use, even if you are not using the theory totally, some of the basic principles you can use. Some of the basic principles means, say for example, certain food items have got high calorie value. So if you are taking that food item, you need only take less food. So these are all some of the nature's principles which we can use. And this is how biomimicking we can do. So before starting anything, suppose you are going to design a chemical plant, suppose you are going to design a building, suppose you are going to design a machine, first to see what, if the nature designs it, how it will look like. Nature's design you should think of. If you think of the nature's design, definitely your design will be more nature friendly, and you are going to use very less resources, and you are going to have very less harm on the environment. That is it. Now let us go to the last slide. Okay. Now I think exactly 1 hour we have taken for this presentation. Now we are going to the second presentation. See the next one. Okay, now we are going to this presentation on Environment Impact Assessment, EIA. See the next slide.
Environmental Impact Assessment or EIA is the process or study which predicts the effect of a proposed industrial or infrastructural project on the environment. It falls under the Environment Protection Act.
Bindu, the video has stuck. Please replay the video. Bindu has lost the connection and is trying to rejoin. We'll wait for half a minute, and if it doesn't work, we will show the video later.
Sir, I'm back.
Okay, you can proceed with the video.
Yeah, I'll start sharing now. Yes.
falls under the Environment Protection Act of 1986. EIA covers projects such as mining of coal or other minerals, infrastructure development, thermal, nuclear and hydropower projects, real estate and other industrial projects. It prevents the proposed activity or project from being approved without proper oversight or taking adverse consequences into account. It compares various alternatives for a project and identifies the one which represents the best combination of economic and environmental costs and benefits. EIA is a formal process in many countries and is currently practiced in more than 100 countries. India notified its first EIA norms in 1994. A new draft was introduced in 2020 but has been widely criticized for its problematic changes in rules. The 2020 draft of EIA allows post-facto clearance. It means any project that comes up without environment safeguards or clearances could carry out their operation. In the new EIA draft, there is a list of projects exempted from the assessment. These include any project the government categorizes as strategic. Once a project is considered as strategic, then no information related to such project shall be placed in the public domain. All inland waterways and national highway projects have also been excluded from the public consultation. There is a provision that exempts construction projects of up to 150,000 square meters from EIA and public consultation. According to the new draft, violations can only be reported by a government representative or the project proponent and not citizens. Any environmental impact assessment is presented for a public hearing. It gives the public a chance to understand the project and its whole process. Inadequate time for public consultation questions the transparency and credibility of the assessment process. But the new draft cuts down the current 30 days for public consultation to 20 days. Experts say most of the provisions in the new draft of EIA proves to be a regressive departure from the earlier version. Recent incidents such as the gas leak at the LG polymer plant in Visakhapatnam and the blowout and fire at the Oil India Limited in Assam are some of the examples that points out the importance of EIA in our country.
Before proceeding to the topic discussion, I just want to know how many of you understood what is basically EIA. Please come to the chat box. Just write a statement. At least some of you. What do you understand by EIA? After hearing all these things. You have listened to a video more than 3 minutes. What do you basically understand by EIA, Environmental Impact Assessment? One or two people can write so that I'll go through it and then discuss further to see whether people have understood what is the concept of EIA. Please put a statement by at least some of you. Even teachers are there in this group, they also will be knowing. In short, what do you say EIA? some definition for EIA or some meaning of EIA? No one is there? Yes. Bina has written, assess the impact of the project on the environment. Yes. Then Lubina has written, EIA is basically the assessment to be done for any new projects or developmental activities regarding the effects to environment on all aspects. Ashwin Raj has written, assessment of the environmental consequences of something, of environment. Okay. Any more definition? And Shailesh Kumar has written, assessment of impacts of planned activities on the environment. Baby Tessie has written, to bring about harmony between man and environment. One or two more we can accommodate, and I will start discussing. Prajisha has written, assess the impact of some human activities on the environment. Okay, so Prajisha is coming very closely to the meaning. Anjana has written, environmental impact assessment is a process of evaluating the likely environmental impacts of a proposed project or development, taking into account the interrelated socio-economic, cultural, and human health impacts, both beneficial and adverse. Yes, Anjana has given the best definition. Right. It is very close to the textbook definition of environmental impact assessment. And Mary Sunida has written, when you harm the environment, some impacts are there. It's a reminder, I think. Then Bushra KK, assessment of environmental consequences of a plan. Okay, I'm happy that at least some of you have understood what is the meaning of EIA. Now, let me simply say what is EIA, other than textbook definitions or general statements, or Bushra has written something more. Assessment of the that I've read already. Okay. So and Mary Sunida has written, when you harm the environment, some impacts are there. Okay, it's the same thing, not different, same thing. So let us come to what is basically EIA. EIA is concerned with human activities. Of course, other than human activities, impacts can be there. Say, for example, wildfire occurs in many countries like Malaysia, Australia. Even now, it's a big problem. Indonesia, New Zealand, wildfire occurs. Most of the wildfire may not be human activity, because some of the wildfires also can be human activities. For example, some primitive tribes burn the wood so that they can take away the burned wood or charcoal from it. That is another thing. But normally, a wildfire may not be a human activity. The fire can occur naturally in the forest. When two bamboos have friction in between them, or they just rub each other, fire can come. Or when some two trees, for example, in the Vedic science, we make the yajna by havis. Havis means fire. That havis is made by a particular timber, by rubbing it each other. We call it as the irony timber. When we rub the irony wood each other, it makes fire. That means wood can make fire. So in the forest, fire can be naturally generated. That is there. So it's not a human activity. But environment impact assessment is concerned only with human activity. It's not concerned with the natural activities which is going on. But in continuation of the human activity, something is happening in nature. That is also coming under environment impact. For example, you are removing a lot of earth from a slope. The remaining slope may slide and come down, landslide. Then the landslide has happened naturally, but its cause has been man-made. So that is coming under environmental impact assessment. So environmental impact assessment is, in a nutshell, assessment of what happens as a consequence of the human activity and harmful to the environment. If it is something good to the environment, that also can come under the environment impact assessment. Say, for example, if you are conducting an environment impact assessment for COVID-19, you will find that so many good advantageous things have been there. The fauna and flora have flourished in this period. The climate has become better. The waste disposal has reduced. These are all positive things which have happened because of this COVID-19. So that is also an environment impact assessment, but not man-made it is. So only when it is man-made, we assess it as environmental impact. If nature cures something or nature destroys something, that's not coming under the EIA. Okay, so EIA involves identifying the impacts of what? Of human activities, or more specifically, predicting the characteristics of the main impacts and evaluating the significance of the residual impact. What do you mean by residual impact? Say, for example, there's a lightning and thunder. Lightning is the impact. Thunder has got no impact. But thunder is a residual impact. If a lightning is very heavy, it will be followed by a huge sound. That is what is thunder. So thunder is a residual impact and lightning is the major impact. Like that, some of the human activities will have major impact and some of them will have even residual impact. Like say, for example, the dodo birds in Mauritius, there were dodo birds and dodo trees. Dodo birds were killed by the people for eating purpose. They used to give big eggs and their meat was also very tasty. The dodo birds were killed by the humanity, by the human beings. That's a primary impact. But after some years, they found that the dodo trees are also vanishing. Nobody removed that tree, but the trees were vanishing. Then hundreds of years later, not hundreds of, some scores of years later, some scientists studied why the dodo trees got extinct after the dodo birds got extinct. They found that the dodo trees had a nut which had a hard shell. That hard shell will not break by itself. So the dodo birds used to eat this fruit, and this hard shell used to break inside their stomach, and their excreta had the nuts in it. And these nuts only gave birth to new trees. The new trees came out from these nuts, which came from the excreta of the dodo birds. So when dodo birds were extinct, the excreta was not there, and the nut by itself was unable to break. So it didn't replenish. That is how the trees also got extinct. So the reaction, so first one is a man-made action, but the second one is a residual impact. This is the best example. Let us see the next one. We have a lot of definition for environment. We have already defined all these things. Environment is basically the biotic and abiotic environment around us. Biotic environment are the living organisms, and the abiotic environment are the non-living organisms, which are all around us. Okay, now see the next one. What are the environmental impact assessment methods? Normally, we have 6 methods. For environmental impact assessment, there are 6 methods in vogue. The first method is called checklist method. I'll explain this. The next method is called matrices method. The next method is called networks method. And the next is called overlays and geographical information system methods. And the next one is called expert system. Expert system means making a computer and using the computer logic to estimate is called expert system. We can develop even expert system programs for it. Then the last one is called professional judgment. An expert can predict what will happen. Say, for example, in last class, I have told that Stephen Hawking has predicted that the life of the humanity may be for 100 years more. So that is a professional judgment. It's not a prophecy. Prophecy means just like a Jyotisha. But professional judgment is not like that. Professional judgment is based on facts and figures and observations done. Now let us see what are the these methods one by one. These are methods used for a checklist means that is not clearly visible, doesn't matter. I just wanted to show you a checklist. A checklist means so many impacts will be written one by one, and then at the end, at the right end of that list, we will see whether it will affect or not. We will say yes or no or partially. That is a method. So if you see how many yes are there, how many no are there, how many partially are there, at the end of it, say like scoring, when we go for NAC accreditation of colleges, we put some scores against everything, yes or no. And at the end of the accreditation process, we add up the yes and add up the no and come to a score. and that score determines what is the grade given to them. Like that, here we will put a score on each question. Each question will be specific, and each question we will write either yes or no or partial. Or if you want, you can put it as percentage, 60%, 70%, 50%, like that. That depends on how you make the checklist. At the end of it, suppose all the full score possible is 1000. Your score added up is coming to say 500. So you can say that the environmental impact of that project will be 50%. So normally we check the environmental impact for projects, maybe for a construction projects, maybe for a thermal power plant project, maybe for a hydropower project, maybe for a steel industry, maybe for a highway project, maybe for a software conglomeration project, maybe for a mining project. All these projects, any human-made activity grouped into a system is called a project. Project is defined as a one-time activity which is unique and which has got some outcome. That is a project. Say the simplest project, normally we say the bearing and delivery of a child is a simple project. So anything like that, I don't marginalize it saying that it is very simple. It is also hectic, but that is an example of a project. Why it is called a project is the outcome is unique. The child you get is the only one in this world like that. So that is, any project has got a unique outcome. Unique outcome means not two projects will bring the same outcome. So the outcome is unique, the process is unique, and the procedure is unique. Then we say it's a project. So every project will have to be assessed by any of the methods for environmental impact assessment. And in the checklist method, we write everything one by one. What are the possible impacts? Say, for example, one question may be, how much area of agricultural land will be affected? One, you can say that, say 60%, 70%, 80%, like that. Like that, another question may be that, how many households will be lost? Maybe it is a hydroelectric project. You can have a question, how many people, their home will be submerged in water? Like that, so many questions will be there. And I have seen even a checklist with around 500 questions in it. Once or twice, I also had to make some checklists for some environmental impact assessment. It will run into hundreds of questions. Even when you make a small Google form for a simple survey, you need 10 to 15 fields, I think. Similarly, this may run into what are the questionnaire? There is no standard. Questionnaire depends on what is the project, what is the impact estimated, and to whom you are going to make. Say, sometime back, I made a questionnaire like this for the environmental impact assessment of Plachimada. You know that the Coca-Cola company was there in Plachimada. I had a funded project and I sent a group of students to conduct the survey, and they were given a checklist for assessment. Even that checklist was having more than 200 questions in it. So even a small checklist depends on what is the project, what the impact we presume, and how it is to be taken care of, what are their sufferings. All these things will be there in a very scientific and systematic way. And whenever you prepare a checklist, the first point to be kept in mind is that this checklist has to be consolidated. Earlier, we had to consolidate it manually. So we used to give score like 1, 2, 3, 4, 5, like that for different choices. Nowadays, you can give even, we have got software which have got cloud attached to software, so that even simple logical questions also you can accommodate. Earlier, that facility was not there. And for consolidating these checklists, now softwares are available. Many of the statistical softwares do take care of even EIA checklists and questionnaires. Now come to the next slide. This is an extension of a checklist. Please next one. This is a next method. I told there are different methods. This is called a matrix method. Matrix method means it is not simply a checklist method. Matrix is the most common matrix form used for this is Loophole matrix. In Loophole matrix, we normally give scores in the, you see that there is a table on the right bottom corner. You can see the tables. So in the tables, you will assign either percentage impact or numerical scores, say maybe from 1 to 10, or maybe percentage from 0 to 100, like that. So different questions will be there on the left side, and on the right top, there social development. This is for social impact. Similarly, you can have for environmental impact. Similarly, you can have for impact on livelihood. So different impacts can be taken in different metrics. All this will be adding up. So there will be questions on the left side one by one, and then on the right top, different aspects will be given. Based on the different aspects matching each other, like all of you the teachers are used to making what is called COPO metrics or POPSO metrics. There you have to put a score based on how much they match. The same procedure is used in Leopold metrics. Of course, we used to make Leopold metrics for real life EIA studies. And of course, in showing on the screen is very difficult. I have seen that in the internet, so many Leopold metrics data are available. If anybody is interested, you have to know the method only. If anybody is interested how to proceed with that, please go to the internet and browse for Leopold metrics. You can see some standard metrics entries given there. See the next slide. The next one is metrics network method. The third method is what is called network method. We have seen the list of methods, and network method, of course, we have seen in the CPM and PERT. Most of our engineers would have studied. Students are yet to study it. In the third or fourth year, they'll study what is called the network techniques in management. They are most commonly studied are CPM techniques, critical path methods. But to an advanced stage, people may study PERT, program evaluation and review technique. And at the postgraduate level, people may study VERT, venture evaluation and review technique. And of course, another technique called GERT, graphical evaluation and review technique. These are all network methods. So similarly, in a network method, what we see is we connect the activities one by one as the consequence of another. Or simply we will say one activity follows the another one, and that follows another one, like that. A chain of activities, we will say, for example, suppose we are taking the case of the dodo tree extinction in Mauritius. What we will first say is that immigration starts to Mauritius. First one. Second one is that the population in Mauritius increase. The third one is that the most commonly available bird in Mauritius, the dodo. Dodo is used as a food by the immigrants. And then dodo population slowly vanishes. And when the dodo population vanishes, the forest area is left idle because there is no dodo. So the fruits and nuts of the dodo tree just fall on the ground and lay idle. And slowly the dodo tree population reduces because there is no new dodo tree coming. Like that, we make a network of activities. And these networks sometimes can connect to each other also. Then we say it's a connected network. In this way, we will see what are the consequential environmental impact of a, say, let us take a hydropower project, Silent Valley. Silent Valley was not permitted by the government of India. Indira Gandhi made it a national park. But before that, let us assume that Silent Valley was given as a hydropower generation station. Let us assume Silent Valley was given as a hydropower station. So how the EIA by a networking method will do? First column will be Silent Valley is a dense forest. It's one of the densest forests in India, and it's a highly monsoon forest, rich in most of the trees, and even very rare species of animals like the lion-tailed macaque and such species are there. And of course, Silent Valley is very rich in one being, that is what is called the leech. Leech we call in Malayalam as Neeratta. Once when I went to Silent Valley, one leech, this leech has got a peculiar capacity. This leech is only 2 or 3 centimeters long, but they have got a peculiar capacity. They can sense a movement even 15 meters above. I just got wonderstruck when the range officer Silent Valley told us that the leech has got this capacity. If you are moving 15 meters away from that, this small organism will make a jump and exactly will catch on to your nerve, your vein, exactly will catch on to your vein, and even without you knowing it. See, nature has got many wonders. And this happened in my case, and I was allergic to leech. I saw the leech only after so many hours when I found that something is hanging on my leg. Because when this leech takes blood, it thickens and thickens, and it becomes like a big worm. The small leech becomes multiple in times and develop weights. Then only I felt the weight on my legs, on the left leg, and I found it. And of course, we had the medicine with us. The medicine is either salt powder or tobacco powder. We took with us both. So immediately salt powder was poured there. The leech will quit immediately, and it will vomit all the blood it has taken. But what happened is I was allergic. It took years and years for that wound to heal. Some people are allergic to leech. So I'm saying that Silent Valley was such a rich forest. And what happened is, if you make a network for Silent Valley, the first thing is this dense forest. Next is making rods for access. Then the third activity may be taking all the timbers nearby available through these rods. And the fourth activity may be deforestation partially. The fifth one may be the coffer dam being constructed. And when the coffer dam is being constructed, so many hectares of water submerging the forest. And after the coffer dam, the real dam is constructed. Then thousands of hectares going underneath the water. Then all the forest being removed by the vendors or by the anti-environmentalists who want to cut the trees and make profit out of it. And ultimately, the richest forest in the country becomes a barren land. But reservoir is there, sufficient water is there. We produce electricity by it. That electricity we use for planting trees and pumping water for it. It's a foolish thing which we do after demolishing the entire forest. We are making small gardens in front of our house. This may be a network for what is happening in the environmental impact assessment of Silent Valley project. If this network you can expand, I told only 5-6 steps. You can expand it to 1,000 steps if you want, or 100 steps if you want. So each step will have one activity and one node, and each node will be connected to another node by an arrow, which is basically an activity. So we say it as an AOA network or AON network, activity on arrow network or activity on node network. It is the same everywhere. The sample is shown here. See the next slide. The overlay method, that is the fourth method. The overlay method approach to impact assessment involves the use of a series of transparencies to identify, predict, assign relative significance and communicate impacts in a geographical reference frame larger than in the scale than a localized action would require. I'll simply explain what this means. What this means is, suppose you are having some 10 transparency sheets. Okay. You are drawing the beak of a bird on one sheet. You are drawing the feather of a bird in another sheet. You are drawing the leg of the bird in another sheet. You are drawing the tail of the bird in another sheet. You are drawing a fish at the tip of the beak in another sheet. Then all these sheets you keep together. That is called an overlay. Now, how this comes to environmental impact assessment? In environmental impact assessment, we split the entire effect into small things. Say, for example, in the case I told about Silent Valley, first you will say road construction, second you will say the coffer dam construction, third you will say the dam construction, fourth you will say the canal construction, fifth you will say the transportation facilities. All this you take them one by one and see what are the impacts on it, then add up all these impacts together. It is called the overlay method. Because in very big projects, we have to definitely go for the overlay methods because each activity will have its own impact. So overlay method means taking each of the components and seeing what are the effects of that component. That is called the overlay method. Let's see the next slide. Of course, most of these overlay methods were devised by McHarg, and that is why this technique, the overlay method, is called McHarg overlay method, where so many things. Say, for example, if there's a mountain, then you are making a quarry at the bottom of it. Then first overlay, first layer may be how much soil will be taken away. Second overlay may be how much stones will be broken away. Third overlay may be how much plants will be removed from there. Fourth overlay may be how much erosion can take place there. Fifth overlay may be how much landslide can happen there. So all these you add up, it becomes what is called an overlay method. Okay, see the next slide. Then which of these methods we should use? Of course, the other two methods I have already told earlier. I have already told they are the expert system method. Computer expert system we can develop. I'm not going into much because that has to be demonstrated through an expert system. Now expert system are available. Computerized expert system are available now to assess EIA based expert system. And truly speaking, I have not used any of this expert system. I know that it's available. Once I got a PhD thesis for valuation, there a lot of EIA expert system was used. but I just read the results only because I was not knowing the expert system. And to understand a thesis, you don't need what software they used. You have to see what the result was. So I just got satisfied with the result and valued the thesis. So that is why I know there are so many expert systems available. Those who are doing some research work can go through it, because it needs a lot of time to study an expert system, how the input can be given, etc. So which method you use for EIA depends on the type and size of the proposal. Say, for example, you are going to make a small pond. You don't require any of these methods. You go to the last choice of the method. Last choice is what? Professional judgment. You call an expert man and ask him what will happen. I also had this experience many times. Before taking up a project, people will call, sir, can you please come and what is going to be the impact? So I'll go there. Maybe it's going for a construction very near to the railway track, or it is going to be a construction near to a very big pond. These are things which we commonly come across. Just by seeing it, if you are a bit experienced, you will be able to say what is going to be the impact. But it is a complicated project like a hydropower project or a nuclear power project. You cannot predict like that. You have to conduct a lot of study, and the EIA report has to be approved by the governmental committees, by the environmental committees of the government. Then only that project will be given approval. So the methods by which we have to make the study depends on the size of the proposal or the size of the project, the alternatives being available, whether some other viable alternatives there so that this project can be avoided. Then the nature of the likely impact, how far-reaching will be the impact. And you know that once a study was conducted at Bhutan Ghat in Idukki district, they conducted a study for atomic power plant. And that result also came, it was very popular. And of course, the impact at that time was told that if like Chernobyl, what happened? If that nuclear power plant collapsed, the impact may span to around 3 to 4 lakhs people minimum. On seeing this, I made a proposal to the committee that then better make it at Attapadi, because Attapadi is wholly surrounded by hills. And at that time, the Attapadi population was only 22,000. So it is better to keep a peril for 22,000 people rather than going a peril for 3 to 4 lakhs people minimum. So these are some of the cases where EIA can help. Of course, if you conduct the EIA, they would have come to the same result, because Attapadi is surrounded by hills. The nuclear radiations will not affect much of the people other than those staying in Attapadi. Maybe if a nuclear power plant came there, definitely the Attapadi population would have reduced also, except the aboriginal natives. Others would have left the place because people are afraid. You see what happened in Tirunelveli district, in Kanyakumari district, when that nuclear power plant has happened. None of the nuclear power plants has no 100% security assurance. Though 99% assurance is there, 1% non-assurance is always there. Even Chernobyl, which was one of the most guarded power plant, has broken. So there is a possibility that even nuclear power plants can break. So depends on what are the impacts. Especially if you go for a nuclear power plant, the EIA study has to be very comprehensive. Then the experience of the EIA members is also very important. Experience of the EIA important. If you go for an inspection somewhere, whether it is a college or a factory or any other establishment, a very highly experienced inspector can immediately locate what are the things you want. Like when we go for inspecting a college for, say, NBA accreditation or NAC accreditation, I always found that most of the members, the first day evening, we will have a meeting of all the assessors. Normally, the assessors will be 3 to 6. We have a dinner meeting on the first day, and in the dinner meeting, all the assessors will give an open opinion, what they feel about the institution. And I have always observed that all these observations are almost near to each other. Why? Because they are all highly experienced. And if at all there is a newcomer in the list, we will immediately identify that he is a newcomer, because his expertise will be slightly different. He may not be able to see the things by the past experience. So that heuristic part will not be there in him. This is same with the environmental impact assessment also. If there is a team of members, they are highly experienced, their judgment will be much, much important than any theoretical statements which can come up. That is why whenever the government is appointing EIA committees, say Kasturi Rangan committee or Gadkil committee, which are basically EIA committees, Kasturi Rangan or Gadgil are some of the most eminent experts in the country on EIA. They have well learned and they have been exposed to so many projects in India and abroad. So the committees headed by them will definitely have very high knowledge. You know, the Sahyadri EIA was done by them. And definitely the Western Ghats have benefited out of it because so many controls have come. Of course, in Gadgil was a very conservative environmentalist and Kasturi Rangan is more of a practical environmentalist. That is why their EIA reports are slightly different. Kasturi Rangan has got some concern for the livelihood of the people, but Gadgil was concerned only about the Western Ghats and its survival. He was not even concerned about the survival of the people there, and that is a slight difference. So I'm saying that the team, the EIA team, will have its own inputs, its own background, so that they'll be better judges on what happens. See the next one. So in any EIA, there will be a baseline condition. Baseline condition means what is a base with, say, for example, we have all heard mean sea level. Mean sea level is the sea level with respect to which the elevation of a place is expressed. India used to have Karachi mean sea level because Karachi that time was in India. So when Lord Everest made the survey of India, the GTS, Great Trigonometrical Survey of India, he was the Surveyor General. Lord Everest was the Surveyor General of India in the beginning of the 20th century, 1900 and 1901. At that time, the survey started for the GTS. And of course, that is in his name only Everest mountain is named. Mount Everest is named after Lord Everest, who was the Surveyor General of India. When he started, he fixed some baseline for the measurement. That baseline for the elevation, reduced level of any point was taken as the Karachi mean sea level, because Karachi mean sea level used to be without much variation and a calmer port. That is why it was taken. Anyway, even now we are continuing with it, though Indian counterparts have come up. Karachi sea level is now, even now, the established sea level in India. So current conditions, current and expected trends, effects of proposals already being implemented and effects of other proposals yet to be implemented will be there. So when you make an EIA study, what is the present position? How it will change tomorrow? What are the effects right now? What is going to be the effect tomorrow? All these things will be discussed. Okay. And let me ask a question, whether any of you have come across any EIA report so far. I just want to please come to the chat box, whether any of you had a chance to read any EIA report so far. So many are available on the internet. Even reports prepared by me are also available. You get a lot of reports on the internet about EIA reports of different projects. Has anybody seen any report, just to see whether there is someone who is exposed to this? Just come to the chat box and say, I have seen the report of so-and-so. No. Shailesh Kumar says no. Anybody, if you have seen a report, you just give the name of that report. Nobody else is responding? Only Shailesh Kumar has said that no, he has not. But now search the Ashwin Raj also says no. Now I suggest that you search the internet. Come across one report. That's a good experience for you. And obviously, if you want to be a member of the committee preparing the EIA, you have to be well established. People should know that you are a well-known environmentalist and you know something about environment. So if you do some well-acclaimed projects on environment, you may be taken as a committee member for preparing environmental impact assessment. Otherwise, there is no qualification required for it. If you are an expert in the field, it's not based on what is your PhD or what is your MTech or MSc, you are taken as an expert, because in Kerala now, most of the projects, the reports are being submitted by the Kerala State Biodiversity Board, Kerala State Pollution Control Board, and they entrust to some expert committee. The committee makes it and submit to the Pollution Control Board. They give to the Biodiversity Board. They give to the government for further. But individually also you can have. For example, when I prepared the environmental impact assessment for the Plachimada project of Coca-Cola, that was an individual report. There was no committee. I took the help of my students only, but the government accepted it. That also can happen. Of course, it depends on the project and how you do it and what is the depth of your study. Only if people feel that you have done something worthwhile, they will accept it. So nobody should come and ask me a question. How can you become an assessor for an environmental impact assessment? That is natural growth to that level. There is no examination, no qualification required for that. If people feel that you are good enough, and of course some legal cases are coming in the court, court will ask the public prosecutor or the attorney who should be nominated. That also can happen. Then they can nominate some good assessor. Nowadays, so many companies have come up. Nowadays, environmental, this is a process which has happened in the last 2 decades. So many environmental impact assessment agencies have come up. These agencies do study. Agencies are at Trivandrum. There is an agency, Center for Environment and Development. At Delhi, that what is that agency called? I forgot its name. They are having a so many such agencies have come up. They conduct study and give the report. You only have to pay for it. They are experts in it. Okay. Now let us see the next slide. And this gap, you see there, bold letters it is written. That is called the environmental impact. If the project is not there and if the project is there, what difference it makes? Say for example, what is the environmental impact of Coca-Cola factory in Plachimada? How we will assess? If the project was not there, how would have been the water availability? The project is there, what is the water availability? So the difference between them will give what is the impact of that. Similarly, another impact. Say you are having a chemical industry in a location. You are studying the water before the industry and after the industry. You are saying how much toxins have come in the industry, how much toxins are present in the industry. That you will say it is an environmental impact. So before the project and after the project, a detailed study only can give this. See the next slide. The impact will have very much variability, like the human being. I told that no human being is the same. Your color, your hair, your looks, your eyes, all these things will be different. Like each study will have different characteristics to take care of. Depends on the industry, depends on the location. So the nature of the study, the magnitude of the study, the extent and location of study. Say for example, if you are taking a study on the impact of a quarry on the earthquake behavior of that area, you may have to study. I have seen a PhD thesis written by I have not assessed that. I have only seen on the net. That thesis was written by some candidate from Osmania University. They have studied the earthquake characteristics of eastern Kerala, especially covering Palakkad, Idukki area. That was a PhD thesis from Osmania University, Hyderabad. And I have seen that they have studied more than 250 square meter area, a long area where the tectonic action they expect. They have found 2 fissures also, especially in it. And only after seeing that, I identified that Palakkad is a very highly earthquake-prone area. So all my students and colleagues from Palakkad, please note, we are not safe in the long run. Palakkad has got a tectonic fissure, so earthquake possibilities there in the eastern parts of Palakkad. That is Kanchikot-Walayar area. That Walayar plate is not that stable one, but may not be in the near future. We had some small tremors. There is such a fissure in Patambi, Ottapalayam area also, where fissures are quite common. And remember, there is such a fissure very close to Tirunelveli, 30 kilometers away from the Secretariat. And if that quake occurs there, even the Secretariat building can be affected. So no place is safe like that, but maybe it occurs once in 1,000 years or so, so we don't have to be worried about it. Okay. Then the duration, then timing, then likelihood of the environmental impact. Certain impacts are probable or improbable, certain or uncertain. We can, like the earthquake I told, sometimes for thousands of years no earthquake can come in Walayar area, but there is a proximity for the occurrence. It can also occur like that. When you study the environmental impact, certain things will be uncertain, so all those things will have taken care of. And if at all it occurs, what is the significance? I told that if earthquake occurs at Walayar, only some buildings will be collapsing. But what happens if earthquake occurs near that Nedumangad area in Tirunelveli district? The entire district, the capital district, will be affected because that area, and that fissure zone is just below a dam also. So anyway, don't get afraid. It may not happen. I was just cautioning it. It has got a likelihood. Okay, see the next slide. Impact also vary. Okay, see the next slide. This is the same thing. Now, we will have ultimately a summary table. A summary table in the sense, all the impact we can quantify. We can quantify in the sense, suppose you are studying the impact of nature, magnitude, extent, location, timing, duration, reversibility, likelihood, significance. You can have what impact it will have on different media. What will be the impact on air quality? What will be the impact on human health? What will be the impact on, say, the drinking water? Like that, you can quantify it. Say, for example, you take a very prominent environmental incident, the Los Angeles smog. Los Angeles smog will have most of the effect on air quality and health. So what is the nature? What is the magnitude? That means how many days it persisted. All these things you can enter in a table. And this table is actually for providing to the decision makers. The summary table is like a synopsis in a PhD thesis. Many of our teachers would have done PhD thesis. You give a synopsis. Synopsis, most of the universities insist that it should not exceed more than 1 page or 2 page. Or it is also called the executive summary. It is meant for the people who don't have much time to read everything. By reading the synopsis, a person should be understanding what is inside. Most of the time when we get a thesis, we study the synopsis thoroughly well. Then only we will value the thesis. Why? If you are thorough about the synopsis, you know what is there in the thesis and what is not there in the thesis. So the synopsis should be containing the essence of what is inside. So the summary table is serving that purpose. At the end of an EIA, we give a summary table so that most of the decision makers will go through the summary table and see what is the entire study inside. No need to study the entire thing inside. They can just go through the summary table. See the next slide. So now prediction is also possible. I've told that a very good judge, a professional judge, can predict some of the impacts. So prediction can be done as a best estimate, and even mathematical tools like statistics or probability tables can be used for that. And of course, certain simple experiments can be done, especially on earthquake. These things are possible, and some analogs can be referred. These are all in some areas of study. This is possible. See the next slide. Okay, this you can skip. This is not much of a concern. So impact, social impact will be mostly on the demography of the place, the cultural changes, community changes, socio-psychological changes. You take a place where earthquake has been there or flooding has been there. Definitely the social pattern will change. Say the cost of the coastal ranges of Periyar. Earlier it was very costly lands. The sea view, the river view lands of the banks of Periyar was very costly. Now nobody is willing to buy land on the banks of Periyar. Why? They are afraid of their lives. So the impact studies will change the social patterns like that. Always. Similarly, if a place is prone to earthquake, a place is prone to flood, a place is prone to drought, based on the impact studies, its values will change. And if you identify that a place is going to lose all its water sources, immediately nobody will come for buying that land, and the environmental impact assessment will be known to the public. See the next slide. Of course, the health impacts you can make into a table, not very important for us. See the next slide. Of course, the economic impacts also, you can list one by one the economic impacts like the agriculture, industrial production, the outputs, and the capital investment. All these things you can make into study if at all you need. What I want you to know is the basic concept of EIA and how it is done. These are all paraphernally attached to that. See the next slide. Then what are the fiscal impacts? Fiscal means financial. Okay, leave it. Next one. Then key elements for assessing impact significance. Impact significance, of course, will be based on certain environmental standards. So let us see these standards also we will discuss next place. I want to discuss 2-3 other slides. This you can just skip. This also you can skip. Skip this also. Okay, this also you can skip. Yes, skip this also. This also skip. There are all explanations which are not much required. Please skip this also. Skip this also. Okay. Here you please come over to, because In India, for environmental impact assessment, there are some rules and regulations. The rules are Environment Protection Act EPA 1986, then EPA Rules 1986, then Environmental Impact Assessment related act is coming in. Environment Protection Act 1986 is modified to undergo the supersession of EAA 1994. In EAA 1994, that is Environmental Impact Act in 1994, some of the provisions given in the EPA Act 1986 are overtaken. So whenever it comes to Environment Impact Assessment, the Environment Impact Assessment Act 1994 is the most prominent one. I just wanted to mention that. So the two guiding rules in India where the courts of law will make judgments on environmental matters are the EPA 1986 and EIA, Environmental Impact Act 1984. Okay, see the next slide. So based on this EIA 1994, all the projects and activities are broadly categorized into two categories, Category A and Category B. Category A is having spatial extent more space, more area is affected, it is Category A. Say for example, there's a small chemical industry coming, it will be only Category B. Whereas there is the Adirapalli hydroelectric project, it will be Category A because hundreds of acres of land will be affected. Whereas a small chemical industry is coming, maybe 10 or 20 acres may be affected. Like that, we classify into Category A and Category B. The next consideration may be based on human health. It is very seriously health affecting or very less health affecting. See the next slide. So which are the projects which require environment clearance? Environment clearance is given by the Government of India, Ministry of Environment, and it is challenged in the courts specially set up for that, green courts or green tribunals. So when you submit a request to the government, the Ministry of Environment peruses the rules and just go through it, and then they will decide all these things. Okay, next one. Environmental clearance is given by either expert committees appointed, they'll give the report to the government and government will give it. Or in the state level, you can have State Environmental Impact Assessment Authority. In many states, it is formed. Kerala, we don't have such a body. Environmental Impact Assessment Authority is not there. Some states, it is there. They give the report, and based on that, the government will give the approval. Okay, next slide, please. This is how the state government can make the SIA. The committee can be made. Skip it, please. And expert committees will be made as and when the project requires it. We will make some expert committee. They will decide on the. So it will be project-based committees. See the next one. Left. Okay, so time is almost. See the next one. These are all not much important. Legal forms and all. Show one by one and skip. If I go on explaining it, it will take much more time. Different stages, screening, scoping, etc. Those who want to study it better, they can just go through it and study it. Because we'll be sending the PPT as such. Just show each slide and skip it. So I have some of the slides I've skipped because they go for an in-depth study of environmental impact assessment. If any of you are interested in becoming an assessor, you can go through all the slides. Not only that, if you want to be an assessor, you should thoroughly study EPA 1986 and EIA, Environmental Impact Assessment Act 1994. Then only you can go into becoming an assessor. You have to be thorough with those two. Whatever things I have shown here are taken from these two. Okay. Now I have seen that many of the participants have left a bit early. That should not happen. And Prabha and Bindu can note down who are leaving early because we have to insist that full attendance is there till the end of the session. So I think we can, if you have got any question, you can just post it on chat right now. I'll wait for 2 more minutes. Then I'll skip. No one has got any question, I think. Okay. No questions. Okay, then. Thank you all. So next session onwards, please ensure that participants are remaining up to the end. Those who are going away, mark them as absent only. Thank you.